Hello everyone, and welcome to this concluding topic related to our reinforced concrete structure series of topics. I appreciate you being here. Honestly, you could have been anywhere else, but you're taking the time to view this video, so I want to recognize that. Thank you so much. For this portion of this topic, we'll chat about precast concrete structures. So let's get started. So what we're going to be chatting about for this portion of this topic are so-called precast concrete structures, which are different from what we've been dealing with so far, which are cast in place. Cast in place concrete structures are the ones that we've been looking at so far. Those are the ones where you create the form, you assemble the reinforcing, and you pour the concrete at the location where you're looking to build your structure, your building. Precast concrete instead, you make all the reinforced concrete pieces somewhere else and then bring them to site. Kind of like what you see in this video here, which is a small assembly of a portion of a building done in Edmonton by, I think it's the supplier is Lafarge Construction, Lafarge Canada. So the whole idea behind precast concrete is that you treat precast concrete construction in a similar fashion as you do steel construction, steel structure. That is, you size all the pieces ahead of time, and then you take them to site and you assemble them properly on site where they need to be. Kind of like what you're seeing on the screen right now. Okay? Now, a little bit of review about precast concrete that you might have seen already in your M&M4. Precast concrete is such that it's, again, made before it's brought to site to be used in construction. So actually, it's fabricated in a plant and then transported to a site for assembly. It comes with some advantages. So for example, greater quality control. And that's because if you're producing these pieces indoor in a qualified facilities, you have better control over the manufacturing of it, and therefore you can ensure that you get the correct strength for all members, which is likely very high. One of the good things about it is related to climate. That is, sometimes in Canada, as you know, when it comes to construction, it's uncomfortable and difficult to pour concrete outdoors when the weather is poor, right? Which can be usually during the winter months, and especially if you keep on going further up north. Well, with precast concrete, because the pouring of the concrete is done off-site in a nice climate-controlled environment, weather doesn't matter. It only matters in terms of assembly on-site of the various pieces. The cost of the formwork are also, and the shoring, that is the support of the structure while it's curing, does not factor in as heavily as cast in place. And that's because when it comes to regular cast in place concrete construction, forms are a huge cost. Whereas if you're using precast, because all the shapes and size are the same, you're basically using the same forms over and over and over to make over and over the same shape and size of members. Okay? Now, it does come with some disadvantages, and that is with precast, you have to include the cost of transportation, right? Because you have to get all these pieces to site. And you might say, hey, what about that? What about having to transport, say, the concrete from somewhere else to site? Well, that's easier. You see, there are a lot more suppliers of concrete than there are of precast concrete material. Another type of disadvantage is that you need very specialized hoisting equipment, right? Because you need to lift all these pieces off of a truck and put them where they need to go in a building, which also means skilled workforce. And in addition to that, then you also have some limitations in terms of the shapes and the appearances of these precast concrete structures because the precast concrete pieces are made to be repeatable, right? So they may not be as appealing, say, as something that you could form on site and give it a nicer appearance. Nonetheless, though, what we're going to be dealing with when it comes to precast concrete, again, you might have covered this in M&M4, You can use it for architectural precast material, so that usually refers to cladding, right? You can cast precast concrete cladding material. We're not going to cover it in this course. What we're going to be dealing in this course is going to be structural precast. So that has to do with all the structural elements of a concrete structure. So when it comes to precast, so making these elements somewhere else, the reinforcement that you can put in them, they can either be the regular reinforcement, like the one that we've seen so far in cast in place, concrete construction, or you can also have pre-tensioned reinforcing or post-tension reinforcing. That basically refers to, you ready? Pre-tension reinforcing is when you're making these precast members, and before you pour the concrete, you actually pull some or all of the tendons, so they're in tension even before the concrete comes in place, and then you clamp them in tension. Post-tension concrete reinforcing is where you do that is you pull on the rebar, the reinforcing that's in the concrete, but you do that after the concrete has been poured and cured. Now, I'm going to link for you a video that kind of compares pre-tension and post-tension concrete, and it does a terrific job doing this. It's a lot more entertaining than I am, but I just wanted you to be aware of these different type of reinforcings, regular, pre-tension, and post-tension when it comes to structural precast. The common shapes that are used are shown here, and we'll chat a little bit more about them right now. We'll start with solid flat slabs. The name says it, okay? The widths of these shapes vary, as do the lengths. The other shape that is common in structural precast concrete construction are hollow core slabs. So called because they look like the solid flat slabs, but they have hollow cylindrical openings going through them. Okay. The next one is the single T, which basically, as the name suggests, it looks like one big capital T. Okay, and it's used for fairly long application, big spans. And then we have double T's, and as the name suggests, it looks like two T's side to side. Okay, we're going to talk specifically about the middle ones, hollow core and double T's. So let's start with hollow cores and double T's. I took these straight out of your textbook, as you can see here. Hollow core slabs are convenient because they are lighter than the equivalent slab. You see, hollow core slab, as the name suggests, has these hollow, empty spaces going through the slab. Here they look like ovals, but typically you'll see them as circles. And the whole point of it is that it reduces the weight of that slab, or that flooring or roofing that you have, which is convenient, right? If you reduce the weight of the structure, you improve the cost and you improve its performance often. They are used for so-called shorter spans. So that is up to about 15 meters, 50 feet or so. They have pre-tensioned, pre-stressed steel in it, reinforcing steel in it, and are becoming much more common now in Canada, in Canadian construction, used usually for non-exposed applications. That is where the slabs themselves, the precast slabs, the hollow core slabs, are not usually exposed to the elements or salt. Okay, so often you'll see them used in schools, hotels, hospitals, retirement homes, sometimes for low-rise application like strip malls or restaurants. And they can be used often for flooring, for floor structure, often too, not as often though, for roofing structure. But you don't see that as often in Canada, having flat hollow core roofs. And that's because in Canada there's a lot of weight imposed on roofs by snow, and usually you get the benefit of having your roof incline so you can shed some of that snow, which then removes the need for a hollow core slab. The one at the bottom, the double T image that I'm showing you here, I took that straight out of your textbook. It's used for longer spans, so that is up to 30 meters or approximately 100 feet, depending on the supplier. It looks like two T's side by side, and they're used usually usually in Canadian construction, in exposed applications. That is where it's okay if the structure, like the double T's, are exposed to the elements. Often, you'll see these used in parking garages, okay? You will find them occasionally in indoor applications, some institutional buildings, depending on their age. But in my experience, typically parking garages are the winning structures for this kind of stuff. Let's talk a little bit more about hollow core slabs and the rules of thumb in sizing hollow core slabs. I took this straight out of your textbook, Appendix B, page 961. The way that you estimate the thickness of your slab is, as it's shown here, H, and you take the span, the expected span of the slab, and you divide by 40. The nice thing about hollow core slabs is that they make the structure of the floor or roof and also are the walking surface. Now you have to pour usually concrete on top of that, as we'll see in a moment, but it's basically structure and flooring all in one. So I'm also going to link for you at the bottom in the description an interesting, cool, short video that Lafarge produced about how to make hollow core slabs in their manufacturing facilities. But let's do an example together. Let's say you've decided you've figured out which direction your hollow core slabs are going to go in your grid system, right, for, I don't know, a working drawings submission. And that you figured out that the span of your hollow core slab needs to be 9,725 millimeters long. Okay, that's going to be the length that you need to span with your hollow core slabs. How do you figure out the thickness of that hollow core slab, H? Well, we're going to use the rule of thumb, span divided by 40. So 9,725 divided by 40, I get 2 out of 3 times 243.1 millimeters. Is that the thickness of my slab? Well, usually you want to round up to the nearest 5 or 10 millimeter. I chose to round up to the nearest 5 millimeter, 245. Are we done? No. And that's because hollow core slabs are supplied in specific thicknesses, right? The suppliers in Canada only make certain kinds of thicknesses. They don't make them to suit unless you're willing to pay for it, and it's really expensive if you do. Typical thicknesses, H's, of hollow core slabs are shown here, 205, 254, and 305 millimeters. Typical widths of them in Canada are about 4 feet or 1,220 millimeters. You can find them wider, okay, but you have to specifically order them. Usually 4 feet is the correct width, the typical width, pardon me. And then how about the length of it? Well, they come up to 15 meters in length, depending on the application for it, at least in Canada. So then in this case, for the example we just did, then you would select a 254 by 1220 by 9,725 millimeter slab. Okay? It's that simple. Now, here's the thing. Because hollow core slabs come in very specific widths, okay, you have to figure out how many hollow core slabs are going to fit within that set of grid lines you have, which means that if they don't fit an even number of times, your edge slabs might have to be custom made, right? So if your grid lines are not spaced at a perfect multiple of 1,220 millimeters, the width of the slab, right, you might have to actually use custom sized slabs on some occasions, okay? Or you might have to actually customize the shape of the slab so that it fits around columns, say. Okay, now I'm going to link for you at the bottom some technical drawings and technical publications that are supplied by CPCI. And that's the Canadian PRECAST, Pre-Stressed Concrete Institute. They are basically the prime source in Canada for technical information about precast, pre-stressed concrete products. And they're basically a body that is there to educate professionals, to advocate on behalf of the supplier of precast products in Canada. Okay, so it's an excellent resource. And like I said, I'm going to link that for you in the description of the video. Now, how about installing hollow core slabs? Because this will help you in figuring out how to detail it in your drawings. Well, there are many different ways of installing hollow core slabs, and some of them can be proprietary, okay? Because it depends on the supplier of the hollow core slabs you're purchasing. Onto steel beams, they're similar. So assuming that we're not coming up with too many proprietary type systems, this is a common way of doing it. That is, you put the slabs onto a steel beam, you somehow fasten them, and then you fill in the voids with concrete. Okay, this is one way to do it. Another way to do it is the one that I showed you previously. I think this was for assignment 1, if I'm not mistaken. Okay, and you can go back to assignment 1 and look at it, and we'll chat a little bit more about this. But what you can see here is there is a steel beam with shear studs, and then the ends of the hollow core slab is slotted with a keyway so that they fit onto the steel beam, and then you're going to put a 50mm rebar that goes that length. Okay. I'm also going to link for you at the bottom 2 videos, the ones that you see the captures here, that kind of show the installation, a video installation of hollow core slabs onto steel beams. Hopefully they will help you. But ultimately, I say also go check out the details that CPCI has provided about this, which are linked for you in the description. And that's because some of them are also CAD details, which may be helpful to you in seeing this. My biggest recommendation though would be this. Google this, okay? Find suppliers, say type in hollow core slabs Canada, and you'll be sent to the various suppliers that you can find, and look at their technical information or technical connections or that sort of information for documents, and you'll find a plethora of information, okay, which will be very helpful for you in your working drawings. All right, so once you install the hollow core slab, the way that I'm showing you here is probably a good way to show it in your working drawings. You put your hollow core slabs onto a steel beam which has shear studs. Remember, we chatted about shear studs a few topics ago. Then you put reinforcing bars that are laid in those open cores, okay? And then what you do is you put a mesh of rebar on top of all of this so you can put the flooring on top of it. So I want to chat a little bit about this mesh of reinforcing, okay? It's commonly known as welded wire reinforcement, or WWR. And basically it's sheets of hashtag shaped reinforcing, okay? Where you get reinforcing going in one direction and reinforcing going in the perpendicular direction. And you can just put it and plop it down where it needs to go. It's labeled usually as a number, multiplication sign, a number, multiplication sign. So an example I give you here for a welded wire reinforcing is 152 millimeters by 152 millimeters by 15.9 millimeters. The first number is the spacing in one direction, the second number is the spacing in the other direction of the strands, and the third number is the diameter of the strands, okay? So now that you see then the image from assignment 2 that's on the left-hand side of your screen, you can see what this is referring to, right? The welded wire mesh that you see there. In this case, I think I'm reading it as 152 by 152 by 9.1, it looks like. Okay? And then you pour the concrete on top of that. Now, you'll find that welded wire reinforcements, WWR, are also referred to as welded wire mesh, WWM, or welded wire fabric, WWF. It kind of refers to the same thing. It just depends sometimes, say, if you're dealing in Canada or the US, or with Canadian suppliers, or US suppliers, or that kind of stuff, okay? But it all means the same thing. And that's what you're gonna use as the topping of the slab that you pour on top of the hollow core slab. Now, this slab is not structural, it's basically as a walking surface. And this is also gonna be how you're gonna do, say, the slab on grade for any working drawings slab that's sitting on the ground. You're gonna use a welded wire mesh, okay? That's basically in a hashtag pattern. Okay, let's talk about double T's. Double T's, as I mentioned previously, are meant to be for longer spans, okay, up to 30 meters, 100 feet. They look like 2 T's side by side. I took this image straight out of your textbook, page 961 in Appendix B. And how do we figure out the depth, the H of the double T? Well, you take the span that's expected to cover it and divide by 28. And then I'll also tell you how to figure out the width of that double T, the top part, and then the width between the vertical portions of the T, which you see here are half of the top width, okay? But first, I want to let you know that I'm going to link for you another video by Lafarge that shows how double T's are made in their plant, okay, which is a common way of doing it. So let's do an example. Let's say you figured out that the span you need to cover in your drawing is 9,725 millimeters, okay, just to pick a number. So what is the H, the height of that double T, according to your textbook's rule of thumb? You take 9,725 divided by 28. I get 2 out of 3 times 347.3. I then round up to the nearest 5 or 10 millimeter. I round up to the nearest 5 millimeter. I get 350 millimeters. Does that mean I'm done? No. Just like with the hollow core, you then have to go and select the closest size that is available by the supplier, right? Because the supplier making specific sizes. So the typical sizes for the height, the H of double T's, can go anywhere from 300 millimeters in depth all the way to 1,000 millimeters in depth, okay? And they usually go in increments of 100 millimeters. So 300, 400, 500, 600, 700, so on and so forth. The typical width, W, of double T's come in either 2,400, 3,000, or 3,660 millimeters, okay? So the width that you select depends upon the grid line spacing that you have, right? Because you want the most number of the same size double T's that you can place, and maybe only one or fewer, right, at every grid line spacing that is custom sized because it doesn't fit the width. In terms of length, well, the lengths come in specific lengths depending on your supplier, but they're going to be under 30 meters. So in this case, say for this one, it would be 400 millimeters wide, right? Because that's the largest, closest to what we need. Sorry, 400 millimeters deep. Width, I guess you could figure that out depending on the spacing of your grid lines. I picked 2,400. And then in terms of the span, 9,725. Okay? Now here's something that's important about precast concrete elements. If you're using precast concrete elements, sometimes if you're set on using them, you may have to maybe adjust some of the spacing of your grid lines to fit precast concrete elements, or be prepared to order custom-sized precast concrete elements, right? Because the whole point of using precast concrete elements is that you can basically order them off a shelf. Okay, that's why they're so cost effective. But if you choose to select elements, precast concrete elements that are not easily available, they have to be custom made, the cost shoots up. Okay, now that might be fine if you're designing a building that needs to make a statement and you have a crazy budget. But if you don't, then it's more cost effective to adjust the spacing of your grid lines to then fit precast concrete members, okay? So keep that in mind. Don't forget that third unspoken limit states, right? Finances, okay. I'm then going to link for you also some technical information and technical drawings that are provided by CPCI relating to double T's. I recommend for double T's the same thing that I said about hollow core. If you want to find some drawing details, construction details, installation details, Google double T Ontario or double T SLABS Canada. And if you look through some of them, some of those websites, the suppliers, they'll provide you with drawing details or connection details or even photos of how to put them together, okay? The other thing to mention then is about installation and connection of double T's. There are many different ways of doing this, and some of them are proprietary. That is, they can only be done according to the instructions provided by the supplier double T's. Onto beams, double T's can be installed in a variety of ways. I'm showing you here a video of how this company does it. But I mean, there is a whole bunch of different ways that are done, okay? My recommendation to you is look it up. And by that I mean, see what the various companies offer and choose the best method for what you're looking at to design. That's it. I want to thank you so much for your time in viewing this, and I appreciate your patience. Thank you so much, and have a lovely day.